Hi everyone. In this video, we are going to see how to deploy a Cloud Run function with the help of GCloud utility. GCloud CLI is a command line tool provided by GCP platform to access the GCP resources outside of the GCP platform. You can also access GCloud CLI from the GCP console itself. Here, you can just open the GCloud CLI and then execute all the commands. You can also install GCloud CLI in your local system, and once you have that, you can log in into the GCP account, and then you will be able to access the GCP resources from the GCloud CLI. To install the GCloud CLI, you can go to this documentation. Here, you will have the steps to install the GCloud CLI based on different operating systems. Once you have installed it, you need to authenticate yourself with your GCP account. For that, you can access the authentication page, and here authenticate for using the GCloud CLI. You would need to run a couple of commands such as gcloud init, gcloud auth login. Once you have run this command, it will ask you to log in into your GCP account, and it will authorize the GCloud CLI to access the GCP resources. We can deploy a Cloud Run function or any other resource for that matter. For deploying a Cloud Run function, you need to run a command gcloud run deploy. And here you will see the command gcloud run deploy, name of the function, code you have within a specific source location. That will be uploaded to the cloud storage, and then it will create a container image. We have the name of function. If we are deploying a Cloud Run function, then we need to specify ---- function. If we are deploying a Cloud Run, so we can skip this. This function will have a name of the Cloud Run function, which is fully qualified name of the class. That is what we have already seen as an entry point. We have to provide the base image. This would be the image. Based on this, the Cloud Run function will create a container image, and it will use this particular base image. Based on different runtimes, you can select the base image, Java, Go, Python, and there are different languages. For each language, you will see a runtime ID. For Java 21, we have base image as Java 21. So this runtime ID we will be referring within this base image. And here we have the region. Wherever you want to deploy the Cloud Run function, you can provide that region. If you want to specifically upload this container image to a specific artifact registry location, then you can provide this option. Otherwise, you can skip it. It will go to the default location of the GCP platform. Here, within this particular browser window, you have option to edit this. You can provide any detail here, such as the name of Cloud Run function. You can also provide the function's entry point, the fully qualified name of the class, and other details as well. Once you have updated this, you can copy it and run this command in your local system. Here within the code, I have couple of Cloud Run functions. We have spoken about these Cloud Run function in my previous video, where we have seen how to test them in a local system. Now we will deploy these functions. Here we will start with hello HTTP function. This is the Cloud Run function for HTTP based trigger, and I have updated this command here, gcloud run deploy, name of the Cloud Run function, source location. You can either have the dot, that means the current directory. If you are running this command from a current directory where you have the source code, then you can directly use that. Otherwise, you need to provide the location of this source code. I am within GCP service POC. I have my source code within GCP plain cloud function, so I have provided this location here. Then the entry point of the class com.bridge hello HTTP function, base image Java 21, region Asia South 2, and also I have added the ---- unauthenticated. That means this Cloud Run function will be accessed without the authentication token. Just copy this command here and run it. Now it is deploying this Cloud Run function, hello HTTP function. It will upload the source code to the cloud storage bucket, and then it will build the container image, and finally it will deploy the Cloud Run function. If you want to look at the logs, this is the location from where you can access the logs of the deployment. We have uploaded the source code, so it is using the build.gradle, which was the build tool that we have used here. Similarly, you can have a Maven based project as well. If you are uploading complete source code based on your build file, it will build the code and then create a jar of it and deploy it to the container. This build is now successfully done. Here you can see we have this Cloud Run function deployed, revision is created, traffic is set, and now you can access the Cloud Run function within this particular URL. If I just run the curl. Based on the default response, we are getting the response that we have from our Cloud Run function. So this is the response we have built, and here you will be able to see that response. In the GCP console, this is the Cloud Run function that we have deployed just now. It has a deployment type as function. Here within the source code, you will be able to see all the code that we have within the source directory. Most of the time, you would be deploying a jar file instead of the source code. We can do that within the gcloud command, and here, instead of the location of the source code, we can provide the location of the build. For the Gradle based project, you will have a jar file within the builds/libs folder. So we can update that here, builds/libs. Now, here we don't have any build at this moment. I'll run the build command. With this build command, we will get a jar file, and that is there within the libs folder. This is the jar. Here, this is the jar file, and if we open this jar, here you can see the classes com.bridge, and these are the classes that we have within our source code. But there are no classes which are part of the dependencies that we have added. When we will deploy this jar, it will fail because of the missing classes. Because of this, we will not be able to use the jar created by the build command. We have to create another jar which will contain complete classes, including the dependent classes. For that purpose, we have to use some plugin. Within the code, we have used the Shadow jar plugin. This is for the Gradle. Similarly, for Maven, you will get the set plugin, and once you have added that, you will be able to generate a fat jar. With this plugin, we will get a Shadow jar task, and that task will create a fat jar containing all the dependent classes as well. It's running this Shadow jar task now, and let's look at the build folder again here within the libs. This time you can see here we have com.bridge package, and apart from that, there are other packages as well, which are part of the dependencies that we have added within our build. Here we have this source location within build/libs, and now I'll run this particular command. Cloud Run function is deployed now. Let's look at the console. Here we have Cloud Run function, the same Cloud Run function that we have deployed earlier. We would have another revision for it. And if we go within this revision, here within source code, now we don't have any source code because this time it has a jar file. This was the deployment of HTTP function, so we don't have any trigger. Here within trigger, you will not see any triggers. Now we will deploy a Cloud Run function for event-based trigger. Here I have pubsub function. This is the pubsub event-based trigger. Here we just need to change the pubsub function, the entry point, and let's change the name as well. Let's deploy this Cloud Run function. When we will deploy this Cloud Run function, it will be deployed in the same way as we have seen for HTTP function. The Cloud Run function is deployed now. Let's look at the console. Here we have got this pubsub event demo. For the pubsub based event, we would need to also add the trigger. Here we can add the trigger by providing the name of the trigger. Then we just need to provide the topic name, select the service account, and we can just save it. It will add the trigger. It will create a subscription within the pubsub topic. We have another option. We can do it with the help of gcloud command. Here you can create a trigger for pubsub events and just need to provide the name of the trigger, destination run service. We have the Cloud Run function demo. This is our service. Then you need to provide the region. This is out to. Here event filter for Cloud Run function for pubsub based trigger, you need to provide the filters like this. Here you need to provide the topic. I have a topic pp demo. Here we just need to provide the service account. This can be a default service account. Again, you can go here, service accounts. I'll refer to this service account. You can look at the different information here, event ARC locations, regions. From the list here, you can update your Cloud Run function trigger accordingly. And here you have the event types. For different events, you will see different event types. For PubSub, we have the event type here. Now with this, I'm just going to copy this particular trigger. Here now you can see the trigger is created. It is referring to this particular topic and all the details are here. Now if we go to this particular topic, this subscription is created now, and if we publish any message here, it should be reached to the Cloud Run function. So here we have the message that we have published from the PubSub topic. So same way you can create a trigger for cloud storage based Cloud Run function as well. And for that, you just need to refer to the event filter. Here we have the event filter for cloud storage as well. This is all about this video. Thanks for watching and happy coding.